Here we have a problem from June 2017. It is question 28, paper 1, AQA specification. You have the information about the problem. There is a cone that is filled with water up to some height. So the gray part is the part filled with water, and you are asked to find the volume of that part, gray part, which is the water that you put in the cone. And now you have those information, the radius of the cone, you have up to what level the water rises, and the height of the cone. Now you can try to find yourself solution. First you stop the video, find your solution, and then turn the video on and compare it to my solution. Here is my solution to this problem. So what we have here is a big cone, and on top of we have a small cone. And what we do, you want to find only the part from the bottom up, that volume which is filled with water. So the problem is not too hard if you think about two cones, a big cone and a small cone. From the big cone, you take away the small cone. Now the thing is, the two cones, the big one and the small one, are similar cones. So we can find first the height of the small cone, which is going to be equal to the height of big cone minus the height of a small cone, which is 15 minus 9. So the small cone is going to have the height equals to 6 centimeters. Okay, now that's for once. Now the two cones, I said they are similar, so the scale factor of the two cones is 6. It is a 15. Let's say 15. We have the height over height, so 15 over, or 6 for small over 15, 15 over 6, but small over big. 6 is the height of the small, 15 the height of the big cone, and that is 205. Now, having that, we can find the radius of the small cone, which is going to be 2/5 of the bigger radius. This is a small radius, so it's going to be 2/5 of that. So we're gonna find out it's 2/5 of 5 equals to 2 centimeters. So we just found the radius of the small cone, which is 2 centimeters. Now we have everything we need to substitute in the formula for the volume of the cone. So to find the volume of the water, we are going to find the volume of the big cone, volume of the small cone, and do the difference. And we are going to get the volume of the gray part, which is the volume of the water in the cone. So if we want to find the formula, the formula, the value of the volume of the big cone is going to be 1/3 times pi times 5 squared times 15, which is going to give us 125 pi centimeter cubes. Similarly, the volume of the small cone is going to be 1/3 of pi times 2 squared times 6. And that's going to give us 8 pi centimeter cubes. Now, the volume of the frustum, which represents the volume of the water, is going to be 125 pi minus 8 pi, and that's going to give us 117 pi centimeter cubes. So the answer is 117 centimeter cubes. And that is the answer for the problem. That's the volume of the water in the cone. And that's it for 4 marks. That's it.